There is so much we have learned about meteorites, and I could spend this entire class, 9 weeks worth of going through things that we know from meteorites. It's just an amazing thing to get parts of the solar system landing on the Earth, as I've said, and to be able to study them in the lab and study the details that we could never study from telescopes looking at things in the broad sense, or even from going there and using our robotic rovers to look at things. Picking up those meteorites, looking at them at their microscopic scales, picking out little pieces of them, measuring chemical compositions and isotopes. It's just tremendous. I'm going to give you now a brief kind of overview of the sorts of meteorites that we find, and we'll talk a little bit more about the science that we learned from them, but it's going to be just, I'm sad to say, just a sort of cursory brush of the things. So the important thing to keep in mind, though, about meteorites versus the rest of planetary science is that there's still this interesting schism. Schism is not even the right word, but there are people who study meteorites and they can tell you incredible detail about these little pieces of the solar system. And there are people who study the asteroids, the planets, fly there, study things there, and they can tell you a lot about the big picture, about what they're talking about. And it is still exceedingly difficult to connect those two things. Now, the one thing that I showed you in the last lecture was that we can at least connect the timescales. We can use the asteroids to measure the timescales, learn something very specific here. The rest of the stuff I'm going to tell you about meteorites is going to teach you a lot about meteorites and untangling what that story means for the grander scale of the solar system is still work that people are trying to do now that's been very difficult. First off, a quick primer on how to find a meteorite. Walk around and look. Okay, it's not the greatest answer in the world. Walk around the right places and look. There are a couple places that if you were to walk around long enough, I could guarantee you that you would find a meteorite. And that's because they're places where there generally aren't other rocks, and you find a rock and sure enough, that's a meteorite. Where are those places? One of the famous ones these days is Antarctica. It's pretty easy to think about the fact that if you find a rock sitting on top of the ice, that there's something funny going on about it. But more importantly, this particular place in Antarctica where the meteorites are found, it's not just that they've fallen right there, it's they fell over a much wider area and they landed on the ice, got buried, and then glaciers carried them downhill to where the glaciers started to evaporate and deposited meteorites down here at the bottom. So you get this huge collection area finding all these meteorites. Fantastic place. Going to Antarctica is a little bit tough, so maybe that's not something you could go do and find your own, but that's one way to do it. Another place these days that meteorites are found in abundance is the Sahara Desert. You can imagine that the Sahara Desert is this expanse of sand, and if you're going along on the expanse of sand, you suddenly come across a black rock. Well, you might guess that there's something funny going on with that black rock, and it's not from the Sahara Desert, and you're probably right. They often are found in big clumps with many different pieces strewn around. These days, expeditions to the Sahara are mounted because selling meteorites is now pretty big business. So these are actually commercial ventures. I don't think commercial vendors make it to Antarctica to go pick them up there, but the Sahara is not a bad place to go. And then, of course, there are many other places that meteorites have been found. Sometimes it's just people bending down and finding a strange-looking rock. It turns out to be meteorite. More often than not, if you bend down, find a strange-looking rock, it's just a strange-looking rock. It's not a meteorite. But every once in a while, people really uncover real meteorites. Every once in a while, they find them because they saw them streaking across the sky, calculated where they would have fallen, and go out and search and find them there. That's happening increasingly these days as monitoring is happening more and more. So let me show you pictures, at least, of some of the types of meteorites that have been found on the Earth. In general, I'm going to break up the meteorites into two types. Stones, clever name, and irons. And I will show you pictures of all of them, and then we'll talk about the different types of stones, which are important things. First, let me show you what the irons look like. Here's one right here. I showed you this one earlier. Here's another one right here. This one is from Argentina, and it fell in not recorded history, but it fell in storytelling history. It fell in Argentina recently enough that there were legends that this rock had fallen from the sky. Not this particular one, this is part of it, but a much, much larger iron meteorite, and which in fact was buried there in the ground and was known about for a long time. This one comes from the meteor crater in Arizona, and it's just one of a million pieces that you can find scattered quite far from meteor crater. I found this in the desert well outside of meteor crater, and as I said, it's just a little piece of iron. You can go along with a magnet and pick up little pieces of iron. These are the irons. Irons are most distinct when you find them because they're made out of iron. You usually don't find pieces of iron sitting around on the Earth. But the interesting ones that we're going to talk about also are the stony meteorites. The stony meteorites are made out of things that we think of as rocks, silicates. Let me show you a picture of some of these. This is a type of stony meteorite called a chondrite. We looked at some of those in the last lecture. We were in particular interested in the chondrules and the calcium and aluminum inclusions. And here you can see another one of these. You can tell, you probably can't tell very well, but there's some sort of bumpy things on the outside here. Those bumpy things are these round chondrules. And you can sort of see them in through here. There's a lot of round things. All of these round things are chondrules that together make up this chondrite. Clever naming systems, I know. Chondrites, these stony meteorites, are a lot of them are these chondrites that are basically constructed of these sort of millimeter-sized, round, formerly molten balls of rock. It's a very strange thing that's telling you something very specific about the solar system, that the bulk of these rocky meteorites are made up of this one sort of type of thing. This one sort of type of thing must have been incredibly common in the early solar system as these bodies were first starting to accrete. Here's a slice of one of these chondrites where you can really see the chondrules really well. It's hard to know what the scale is here except to remind yourself that these chondrules, these sliced open chondrules, are again a couple of millimeters across. So that's what that scale is there. And you can see they are beautiful round things, these spheres. You can tell they're spheres because when you slice them across, you get the little tops of them, you get the nice round versions of them. Sometimes you see things like they're cracked. You can see a cracked one right in through here. You occasionally see, this one you can't see very well, but this is a pair of them that have merged together. Sometimes you see them broken apart. This is parts of a chondrule that broke. Chondrules. The early solar system, these meteorites that are landing on us are made out of tremendous amounts of chondrules, almost like little BBs in space. A very, very strange thing. I could show you pictures of chondrites all day long. It's not as satisfying as seeing them in real life. If you get a chance, go see some of these things. Here's a beautiful one from the American Museum of Natural History in New York City. Go there, check this one out. You can see it's been sliced open. This is a slice of one of the most famous carbonaceous chondrites. We'll talk about that in a minute. And it's called the Allende chondrite. And they get their names based on where they fell on the Earth. And you can tell this one's different. You see the chondrules all over the place, nice round globules. You see there's some beautiful big splotches of calcium aluminum inclusions in through here, but mostly you see chondrules. But what you also see is in between the chondrules is this black stuff. It's called the matrix, the stuff that holds the chondrules together. So it's not that everything is chondrules. There is glue in between it. And what is this glue? Well, in the previous chondrites that we were looking at, it was just more of the same sort of material that the chondrites are made out of, the sort of rocky material. But in carbonaceous chondrites, the matrix in through here is carbon in forms like graphite, just pure carbon. Carbon, now when I say carbon, you should suddenly sit up and think, ooh, this is really interesting. Carbon, of course, is one of the key components of organic matter, of life, of all these things. We're looking for where stores of this carbon could have been. It certainly could have been in wherever these things, these carbonaceous chondrites, were forming and eventually falling down to the Earth. Here's another carbonaceous chondrite. These are just, I find these spectacular. They're just on this dark matrix of carbon and then just full of all of these chondrules in the middle of there. So what is going on with chondrites? We find them all over the place in the meteorites that we find on the Earth. We think of them as the very first primitive things that were made in the solar system after the calcium aluminum inclusions, or perhaps at the same time as the calcium aluminum inclusions. And yet when we think about the accretion of things in the solar system, we think about the way things start to stick together and get bigger and bigger. That doesn't make chondrules. That doesn't make little millimeter-sized BBs. That makes maybe big dust bunnies or something, or irregular globs. Not chondrules. Why chondrules? Well, you can study chondrules for your entire life, and what you would find is that you can figure out things like chondrules were heated to very high temperatures and then cooled very quickly. You would find that they come in a range of sizes, but that in any individual meteorite, they tend to be all kind of the same size. The range is not very big, but they still tend to be all sort of the same size. There are a million different little aspects of chondrules that you need to try to understand if you're going to put the story together, where they came from. I'll give you a couple different ideas. This is still unsettled. It's not one of these things where no one has any idea where chondrules came from. It's that there are too many ideas, and nobody has settled on yet what the story is. There are some ideas that material was starting to grow and shock waves came in through the big nebula of gas and dust, and those shock waves quickly shock heated the stuff. It formed into these little blobs and then cooled back down as the shock wave went. There are other ideas that they were formed actually by material being pulled close to the sun and then being ejected away from the sun and heated up to very high temperatures very briefly as it was pulled close and then cooling as it was ejected away. Other ideas that all these little chondrules were sort of sorted together into similar size balls by eddies and currents that were flowing in through there. There have been ideas that the chondrules were melted by lightning that occurred inside the nebula. None of these things is really certain. It's an area of extremely active research and extremely detailed research that I'm sort of sad that we don't have time to get into in the gory detail here. But the key point really to take home is that there was some process that seems to have been fairly ubiquitous in the early solar system that led to chondrules being strewn everywhere. And by everywhere, I would point out that I really mean everywhere. Pieces of chondrules have been found in the dust from comets. There has been one flyby of a comet where the dust was collected, brought back to the Earth, and that dust was analyzed. Pieces of chondrules. Chondrules, they're everywhere. In the next lecture, we'll talk about the other sorts of meteorites that we find.